Hey guys, in this video I will make a motion camera with Arduino, ultrasonic sensor and a OTG cable and a USB B type. The ultrasonic sensor detects the motion and sends its data to Arduino. Then Arduino behaves like a HID keyboard. It presses the space button and the photo is clicked in the phone.
Let's see how I made this project. Stay tuned till end.
Hey guys, here is the circuit connection. The HCSR04 sensor trigger pin and echo pin is connected to digital pin number 3 and 2 of Arduino, and the VCC is connected to 5 volt of Arduino and ground is connected to ground. Here I'm using a USB A to B type cable to connect Arduino and my phone. To connect this A type USB to my phone, I'm using this OTG. Here I'm using my phone with a camera. Hey, hello and welcome guys. Here is the programming part. So in the program at first I would use this unit 8 data type which will store the unsigned integer up to 8 bits. Then array is made with name buff. Its size is 8 and its all elements are set to 0. Then here I have defined the echo pin and trigger pin of the SCSR04 sensor or the ultrasonic sensor. The echo pin is connected to 2 number digital pin of Arduino and trigger pin is connected to 3 number digital pin of Arduino. Then here I have defined some variables as duration and distance. We will use these variables later on. Then in the void setup I define these pins, that the trigger pin which will send the ultrasonic waves as output and the echo pin which will receive the ultrasonic waves as input. Then after that here I have started the serial communication with a baud rate 9600. Then in the void loop I make a pulse. First of all I will clear the trigger pin by giving it low signal. Digital write a trigger pin low. So now it is in low position. Then delay microseconds 2. Then after 2 microseconds set the trigger pin high or active for 10 microseconds. uh, then 10 microseconds, so it is low for it is we have sent a low signal for 2 microseconds. Then after that we are giving its high signal for 10 microseconds. Then after that we are just giving it a low signal after 10 microseconds, so it will generate a pulse. So it reads the echo pin, returns the sound waves, travels the time in microseconds. So we have to read that pulse as we have made a pulse by sending a high low low high low high low signals. Here is the variable duration that we have declared earlier as pulse in command to read the pulse echo pin high. So now we will calculate the distance. So here is the variable we have defined earlier. Duration distance is equal to duration into this. This is the speed of sound divided by 2. Distance is equal to time into speed divided by 2, as the time is calculated 2 times when it goes and when the times come back. So we have to take half time to calculate the accurate distance. Then after that, here if distance is smaller than 40, it means that if anyone passes from the sensor, then it will store buff array of index 2 equals 40. This 40 is the key code of the enter button. Here is the enter button and here is 40 is the key code of that enter button. If you want to press space button, then you have to place there 44, both works well in that case. Then after that, here serial dot write buff is the array and comma 8. Then here we have called a function which is release key function. So this function will release the keys when we press enter. Then this function is called. So after pressing enter, it will release the key, this function. This void release key, this is the function. The way we are going to make Arduino UNO as HID device is by changing the firmware, which will allow us to code and use it as a HID or human interface device. Now here I have connected my Arduino to my computer and I am selecting the port number at which my Arduino is connected. After that, I will upload this Arduino program into the board. Here the program uploaded. So here you can see in the comport section, here it's showing comp 17, and I am going to device manager, and in the comp and comport section, here it's showing a serial devices comp 17. For changing the firmware, you have to install Atmail Flip DFU. The link is given in the description. You can download the installer. After installing the software, we have to select the IC button. It will ask for your IC model number. For Arduino Uno, it is 16U2. After that, we need to short these two pins. After shorting the pin, you have to connect the IC with the computer. So click on this USB button, then go to USB, then hit open, and now your IC is connected to the computer. Now you can change the firmware in it. So now we will have to load the hex file. So go to load hex file, then here it's the hex files, the Arduino keyboards, as we want to convert our Arduino as a keyboard. So I will choose Arduino keyboard. Now I will press run. Then after that, start application. Then after start application, you have to remove your Arduino, then replug it. Now it is behaving like a HID keyboard. So now I'm going to this device manager, and here in the keyboard section, here you can see a HID keyboard device is attached. That is none other than the Arduino. If you want to reverse the action, or if you want your Arduino to be normal, then you have to follow the same step, but you have to choose the hex file as Arduino VUSB. So its process will be same as when we are converting Arduino as a keyboard. So but the difference is that the hex file you have to change. So I'll give the all the codes, all the softwares links in the description. Go and download from there, and thanks for watching this video.